Yes, I once again welcome all of you the lecture series of microprocessors and microcontrollers. Now today we are going to discuss the register set of 8051 microcontrollers. You know that 8051 microcontroller has a lot of registers. Nearly we have 32 registers are available in the 8051 microcontroller. So how these registers are accessed? So please wait. Yes, we'll see this. You know that microcontroller has the lot of register sets when compared to the microprocessors. So how you can access all these register sets? Then how you can access all the registers by how to write the some addresses for the registers, where the registers are available in the 8051 microcontrollers. Okay, then how that registers are useful to so functioning the 8051 microcontroller and all we will see in this class. Okay, so where these registers are available first of all. So you know that these registers, most of the registers are available on the CPU. So CPU is nothing but we have the ALU, arithmetic and logical unit. Then you have the then register sets, a register bank. You can also call it as a register bank. Then you have the timing and control unit. Okay, timing and control unit. Okay, you see this three categories. So arithmetic and logical unit as well as register bank as well as timing and control unit. Now we are focusing on this one, register bank. Register sets are you can also call it as a register set. So not only this registers is available in the CPU, these are available in the RAM as well as at the same time ports also. So these registers, remember, not only available in the CPU. Okay, these registers are available in the RAM. At the same time, these registers are available in the IO. So nothing but port 0 can also call it as one register here in 8051 microcontroller. Port 0 can also call it as a one register. Then the same similarly port 1, similarly port 2 and port 3. At 4 ports we have the 4 registers, 4 8-bit registers we are assuming. Okay, out of the 32 registers, this 4 registers is also added. Okay, now see this. This is the brief introduction of the register set. You have two 8-bit registers, nothing but A and B. So register A, you can call it as the accumulator. This is always one of the operand for any of the most of the operations performed by the CPU. Okay, the next one is the register B. Register B is also not, also the one of the operand for CPU performed operations. This register B is particularly used in the multiply and division operations, because so in multiply and division operations, one of the operand is accumulator and second operand is always a register B. Okay, then we have another set of registers are there. Then PSW. This PSW is also the 8-bit register. Okay, PSW means a program a status word. Is also nothing but you can also call it as a flag register. Okay, you know that what are the different flags? Nothing but the carry flag, so auxiliary flag as well as overflow flag, a parity flag, like that flags. In 8051 8086 microprocessor, this this we can call it as a flag register, but in 8051 microcontroller, this statuses we can call it as a program status word. How this program status, the status word is changing the bits. That means you know that flag is a one bit. If it is set or reset, but it is one or zero. It is one or zero. How to set and reset of these flags? So by seeing the CPU, nothing but arithmetic and logical unit is directly connected to this PSW to change the bits of the. Then we have the another 8 bits of 4 registers. We can also call it as a port 0, port 1, port 2, as well as port. Okay. Then another set of registers. These are one category of registers. The interrupt priority as well as interrupt enable. Okay, interrupt priority, interrupt enable. These are also the 8-bit registers. Each one is the 8-bit registers. Okay, this so you know that in 805 microcontroller we have 5 interrupts are having 5 interrupts. Okay, then this is the timer counter or timer controller register. In 8051 microcontroller, this will operate in the timer and counter mode, at the same time serial communication mode also. To operate that timer and counter modes, you can also you can utilize this 8-bit this registers TCON, timer counter registers. Then serial counter registers. So you know that microprocessor is a microcontroller is also operate in the serial mode of data. So these all are 8-bit registers. These all are 8-bit address bit registers. What are the remaining registers? The stack pointer. You know that these are both are common. You know that so you can call it as a data pointer registers. Data pointer register. This is actually a 16-bit register. This 16-bit register you are dividing into the higher order 8 bits as well as the lower order 8 bits. Okay, what is the use of this register? This register is used to access the external memory. Okay, then timer mode. This timer mode, this another type of register is timer mode, is used in the timer and control mode operations. Then this is also the a 16-bit register. So the 16-bit register is two 16-bit registers are available here. Two 16-bit registers. This two 16-bit registers are divided into the 8-bit series. 8-bit registers. Then another one is the serial buffer register or bus registers. Okay, SBUF is used for, this is a 8-bit register. This is used to used in the serial communication. So another one is last one is the power control registers. Power control registers. Okay, power control. PCON means here power control register. CON means here control registers. Okay, so see this. These registers. So all these registers, whatever it may be, a PSW ports and all these registers. You can address these registers only. You can access that registers. You are addressing that registers. Nothing but you can call that registers. Then only it will be. Operated, working. Otherwise, otherwise these registers are not in function. You are calling that registers. How to call that register? You are not calling that by using some name and all. So that registers has the some codes. Where the codes are available. So the codes are available in the RAM. How much memory is occupied the this course? 32 bytes of RAM memory is occupied the this course. 32 bytes. You know that RAM memory, internal RAM memory. What is the size of internal RAM memory? It is of only of 128 bytes. Out of 128 bytes, this addressing of the registers will occupy the 32 bytes. Okay, what is the address size series? What is the address size series? 0000H2. H means here, you know that in hexadecimal format. 2001F H. 32 bytes information. So these 32 bytes is nothing but, you can also call it as a 32. You know that these all are, you can count these registers all are 32 8-bit registers are there. but actually these are 16-bit registers. But this 16-bit register, you know, the TPH, TMOD, TH0, TH1, and these are the 16-bit registers. You are dividing that 16-bit registers into the 8-bit registers. Okay, so what is when you divide this R, so these are the 32 different types of registers. So out of this 32, what is the bit size of the registers? Bit size of registers is 8 bits. So these are you are dividing into the 8-bit registers. That's why these are the 32. Otherwise, this number is not matches to the 32 number, because data pointer register, you know, the DPTR is a data pointer register. It's divided into the two registers called DPH and DPL. That's why it is 32. Otherwise, it is not 32 registers. So these 32 8-bit registers is nothing but is grouped into the 4 registers, 4 register banks. 4 into the 8, 32 registers. So each bank you have the 8 registers. Then how to access these 4 groups? So by accessing these 4 groups by using this pins RS0 and RS1. See this. So RS0 and RS1 nothing but 0 0. See this 0 0 0 1 1 0 1 1. You know that 4 number 0, then 1 2 and 3. You know that 4 4 4. These are the 4. So this RS0 RS1 is used to RS0 means here RAM selection, nothing but RAM selection. You know that where these codes are available? These codes are available. This register codes are available at the RAM. So RS0 RAM selection 0 and RAM selection 1. So by easily accessing these 32 registers, so we are dividing or you can sum up into the 4 groups. These 4 groups you can access by these 2 pins RS0 RS1. Where these 2 are available, RS0 and RS1, these 2 bits are available at the PSW. Okay. Now see this. These are the registers. These are the registers. Whatever we are discussing here, these are the registers. Okay. Now see this. You know that this total internal RAM. So RAM or data memory. So RAM memory you can also call it as a data memory. So is divided into the general purpose registers, with addressable registers, then register banks and special purpose registers. Okay, a 128 RAM. This is RAM. What is the size of RAM? 128 bytes. Remember, please remember whatever you are discussed here and internal memory. Remember the main difference between microprocessor and microcontroller is microcontroller has the internal memory. Okay, so 128 bytes of RAM memory we are giving here. So see this a picture is gives this some small information about the register banks. You know that by accessing, so in thoroughly we'll discuss in this memory accessing topic in memory organization, but a small information here. We'll see this. So by accessing these registers, you know that some different types of registers, you have formed the register banks, series register banks. So for you know you have the 4 register banks: bank 0, bank 1, bank 2, and bank 3 registers. So what is the address series? 001 F 002. You know that 002 the series. This is the address of that register. This will occupy 32 bytes. 32 bytes of out of 128. This is out of 128 bytes. So of RAM, this is RAM. Remember, this is RAM memory. This is RAM memory. Out of 128 bytes of RAM memory, 32 bytes are occupied with this registered bank. So this is direct and indirect addressing. You know, the addressing can be done in direct as well as indirect. So this is the direct addressing mode. So directly you can specify all these registers, whatever DHT, you see this, all these registers. So you can observe this registers. You can observe this registers. You can observe the address of the registers, different addresses of the registers. You will see this addresses of that register. So it will goes to the F0H. You know that what is the value of F0H? F is nothing but the 15 0. So nothing but F is nothing but the 15. So FF, last one is the FF is also there. Okay, see these addresses. These are the you remember this one. These are whenever you want to access a register A, so we will write the code for easy. But actually, that registers are available within that memory. You are no need to. For suppose I will write the program move. So for suppose add a comma b. For suppose add a comma b. For suppose a is one register, b is one register. You know that very well. I'm not mentioning the code address of these registers because these are already available within that microcontroller. So whether these registers are available in the microcontroller, you need not to specify the addresses or the codes for that registers. So see this, all the registers, PS0, nothing but port 0, stack pointer, data pointer, lower order, data pointer, higher bits, then power control register, timer control register, timer mode register, TL0, TL1, TL0, then port 1, then serial buffer, port 2, interrupt enable, port 3, interrupt wide register, PSW register, AC series, nothing but accumulator, P registers. These are the codes for the registers. These are the codes for the register. But you are not some registers. You are need not to specify that codes. But in some registers, for suppose, when you access the port zero you are connected to the some device is called display. It is this by accessing the port is very much similar to the microprocessor. When you access that port, you must represent the code 80. Then only microcontrollers understand you are accessing port 0. You write the code for them. Some registers you must represent the code for them. Okay, this is indirect addressing. So indirect addressing means some additional memory you are taking and allotted the code for this registers. Okay, so see this for our simplicity purpose, these registers we are dividing into the some CPU registers, some CPU A and B registers. At the same time, we have also the temporary register 0 as well as temporary register 1 is also there. But these are not accessible registers. Then program status over registers, and then pointer registers, you know the DPTR registers, then stack point register, then IO ports, you know that 4 ports are available, then peripheral control registers, power control register, serial control register, timer control register, timer mode register, then interrupt enable, then interrupt priority registers is there, then peripheral data registers are timer register 0, then 1. And these are two different 16-bit registers divided into the nothing but the 8 registers. Now we will discuss it in each one. Okay, first one CPU registers. You know that accumulator. Accumulator is 8-bit register. You know that it is a 8-bit register. Accumulator is a 8-bit register. So most of the operations performed by the CPU. One of the operand is always the accumulator. Okay. This one. Yes. See this an 8-bit registers. Okay. Most of the CPU operations performed by the CPU. What are the operations? Arithmetic operations like addition, subtraction, multiplication, division. The NAND operation, OR operation, and NOT operation. Then compare operations. Most of the operations. At the same time, you know that whenever you add any two numbers, the results are also stored at the top. Okay, all these operations, I mean, one of the operand is accumulator. At the same time, we have one special register is there, B register, register B. So this is also the one of the registers that is available on the CPU. Okay, this is also the one operand register, but this register is very much useful in the multiplication and division operation, because in this operation register B is one of the operand whenever you are using multiply or division operations. The multiply a comma b or division a comma b, that's why B is always one of the operand. See here in multiplication operation, one of the operand is or multiplier or multiplicand is B. At the same time, in the division operation, a register B is holds the divisor and also the remainder of the result. So that's why whenever you perform the multiplication or division operation by using the 8051 microcontroller, you must represent or you must assign one of the operand as a register B. Otherwise, microcontrollers doesn't understand and will not, perform that operations correctly. So, what is the location of the? This is the address for that register B. See this register B address. This is see this F0H. What is the register A address E0H? But you need not to remember all the this register nothing but the codes. Okay. So now see this program status code. Now see this is also the 8-bit register. This is also the 8-bit register. Out of the this 8 bits, only 7 bits are 7 flag bits are used. You know that program status word, you can also call it as a flag register. See this, a flag register. Okay, so each flag you can call it as these are the flags. You can call it as a flags. These flags are either maybe set or reset. A set is nothing but the 1. A reset is nothing but the 0. How these flags are set and reset? One way is by seeing the CPU operations. Okay, these are the these are the 7 flags. In 8086 microprocessor, you have the 9 flags that way. That is the 16-bit register. Out of that 16-bit register, you are using only 9 flags. But in 8051 microcontroller, we are using as a 8-bit register for this flag register. Out of the 8 bits, only 7 bits are used. So 7 flags are available in the microcontroller. Okay, so what are the different flags? Parity flag. So overflow flag. Then RS0, RS1 flags. These are the flags that are used to access the register banks. You know that we have the 4 types of register banks. So then flag is flag 0. This is then auxiliary flag. This is carry flag. You know that carry flag. Whenever you are add any 2 numbers, then you will get an access bit that we can call it as a carry flag. Where this auxiliary carry flag is available whenever performing the BCD or arithmetic operations. So nothing but addition or subtraction operations. So in between that one group to another group, carry is forwarded from group 1 to the group 2. For suppose that we can that one we can call it as the auxiliary carry. Please remember in microprocessor and microcontroller way, in digital microcontrollers, whatever it may be, a carry or borrow both are equal. Okay, see this. See carry used in arithmetic and logical and Boolean operations. Whatever. You know that auxiliary carry. This is used in the arithmetic operations. So general flag 0. Nothing but see this. This 2 bits RS0 and RS1. See this. These 2 bits are used to access the register bank. See this. So this 0 bank 0, bank 1, bank 2, bank 3. You know that out of 32 registers, you are divided into the 4 banks into the 8 registers. Each bank we have the 8 registers. Okay. Then overflow flag used in the arithmetic operations. You know that what is overflow flag? So whenever we are performing the any multiplication operations or some addition operations, what is the size of that register is 8 bit. So but that resultant you got the more than 8 bits, then this flag is set. Okay, then parity. You know that parity. Then it is of even parity as well as the odd parity to check whether the sending data, receiving data is correct or not. That's one of the method to check that information. Okay. The next one we have the data pointer. What is the use of this register? What is the use of this register? This register is used to access the okay uh, external data series. This register is used to access the or addressing the external memory. External memory. So that is the use of this register. So this is the 16-bit register data pointer. Is nothing but the DPTR. But there is no code for this one because the 16-bit register is divided into the DPH higher order. See this is the 16-bit register. This is 16. The 16-bit register is divided into the 8 bits. 8 bits data pointer register lower, data point register higher 8 bits. See this 8 bits. So this is the DPL lower order 8 bits. This is the higher order 8 bits. This will have the codes, but this DPTR there is no code is available in the microcontroller. When you access this DPTR, you are not accessing the 16-bit DPTR. You are accessing only either maybe of 8-bit DPL or either maybe of 8-bit DPH. See this. The codes for accessing this series. Series DPH DPL. What is the code for this one? 82 and as well as 82. There is no such DPTR is the series ever directly available. This is available in the combination of DPH and DPL. Okay, this is okay. So these are the codes. DPL is 82H, DPH is 82H. The next one is the stack pointer. So for the stack operations, for especially for the stack operations, you are using this stack. Okay, so for accessing this stack data and all, we are using the instructions called push pop as well as call and return instructions. So what is the accessing or what is the initialization of the stack point? What is the code for this one? This is the 07H. So this is also the an 8-bit register. Okay, the next one is the ports. You have 4 ports are there. Port 0, port 1, port 2, port 3. These are bidirectional ports. So these ports are of 8 bits. 8 bits. This is nothing but an 8-bit register. These ports we can also call it as the registers and 8-bit registers. Okay, these are the ports here. So now see this port 0 address is 80H. What is what is 80? How it is formed 80H? Pin 7 is 1. See, I will write the code is 000. This is 8. Okay, this is 8. All remaining bits are 0. This is 0. So this is 80H. Okay, this is 80H. Similarly, 90, nothing but 1001. Remaining all are 000. We are dividing 4 bits. See this. We are dividing 4 bits. 4 bits. This is 9. These are all the 90H. That is the way you write the or you can access the IO ports. But whenever you are accessing these input output ports, remember IO ports means input and output ports. You must specify the codes for that one. In the programming also, you must write the code for this registers. Then only you can access the port 0, port 1, port 2, port. But remaining nothing but accumulator or accumulator register or register B or some PSW. You need not to specify the code files. Then peripheral control registers are one of the peripheral control registers, power control register. Remember, PCON means a power control register. Power control register. So what is the use of this power control register? So it is used to control the operations of the 8051 microcontroller in power. So what is the address of this one? This is the 87H. So this is also the 8-bit register. 8-bit register. This 8-bit register only ideally you are using 2 pins for ideal mode as well as the power down mode series. Ideal mode as well as pin 0 as well as nothing but bit 0, bit 1 is used for ideal mode as well as the power down mode. So one of the important point, PCON is not a address register. Okay. series. SMOD, you know that serial mode of serial mode. So SMOD means a serial mode, serial mode. Okay, then GF1, general purpose user flag, then power down. You know that I said these two are important for this register. So power down bit as well as idle mode bit. So what is the power down bit? What is the this mode will in case to enter power down mode, set 1 or set so nothing but you can set this pins 1 1. So there's no these are the positive values, so that's why you can put into the 1. But what is the baud rate of this one? Serial mode, serial mode. So what is the baud rate of this one? A baud rate is nothing but the rate at which you can transfer the data in communication. How fast you can transfer the data in communication, that you can call it as a baud rate. Baud rate. Okay, now see this. This is baud rate, definition of baud rate. The baud rate is the rate at which information is transferred in the communication, especially in serial. I missed that word, serial. Serial communication. Another one is the serial control registers. So this is also used in the you can control the 8051 microcontroller in serial port or serial. So what is the address of this one? This is the 98H address location. It is available in this registers. So where these addresses are there, you know that these addresses are there in the RAM, internal RAM memory, internal RAM. So by using this register, you can control the operating modes of the serial port as well as the baud rate of serial port. It's nothing but you can send and receive the data. How much speed you can send the information, how much speed you will get the information. So you can control the speed, data transfer speed also. At the same time, you can control the different modes of that serial communication. So that is done by these three modes. Then remaining you will see it in what are the each and every pin series. So these three pins, SM0, SM1. So this three pins will gives the serial port are that ports, three different ports. So I mean I mean this is the, whenever it is SM2, this is the multiprocessor. So then receive enable bit, then transmit 8 transmit 8 bits, receive 8 bit, interrupt flag, receive interrupt flag. You know that you must remember all the things. Okay. Yes, see this this is then another one. Then see this, what is this three modes will indicate. SM0, SM1 pin will indicate. So this is the this is very much useful, you know that these are where you can use this register is especially used in the serial. So by performing the serial mode in 8086 microprocessor, you can use the USART as a one of the interfacing device. USART, universal synchronous asynchronous receive and transmit. Here they can represent UART. You are not confusing in your examination. You write USART. So that USART device is readily available in the microcontroller. It is already inbuilt in the microcontroller. So that's why serial communication is possible, easily possible in the 8051 microcontroller. But in microprocessor, whenever you are performing the serial mode of data transfer, you must interface the USART as a one of the control. USART, universal synchronous asynchronous receive and transfer. So you see this. What is the serial mode of data transfer? Is nothing but if one line is sufficient to send the all the information. In serial mode, we are using only one line to send the data. Nothing but bit by bit, bit by bit information you can send. So that's why one line is sufficient to send the data. At the same time, one line is or one bit is sufficient to receive the data. So for suppose this is the for suppose you have the 8-bit information. 8-bit for some 1000, then 0001, 8-bit information. So this is the LSB, this is the MSB. So out of these 8 bits, so first bit is going to the first by using this line, then after second, then after the third, then after fourth, fifth, sixth, seventh, eighth, then this. This is the way you are sending the information. So one line or one line is sufficient to send the 8 bits. Is nothing but bit by bit information. So that is the serial mode of data transfer. So where you can use this serial mode of communication. So these are used in the communication equipment, especially you are using your cell phones or satellite signals or internet. All these are the serial mode of data transfer. So why we are coming to serial mode of data transfer? To reduce as the cost, at the same time to reduce as the nothing but noises in the lines and all. You are coming to the serial mode of data transfer. So not only by using this register, we are not only controlling the serial mode of data transfer, we are also controlling the speed of data transfer, at the same time data receiving capability. So see this. These are also fixed with the baud rate. So baud rate is depends upon the frequency of that oscillator. So you can control that oscillator speed also. Then next type of device is the timer control register. This is also the 8-bit register. This is also the 8-bit register. Okay. So you know that microprocessors operate at the timer series, timer and counter mode. Remember, counter mode as well as the serial communication mode. We are discussing all these topics in later. Communication mode, then a power control mode. Power control mode. By accessing these three, we are using different types of register, TSCON, timer control register. Then by serial communication, SCON. For power, you are using PES or PCON register, something register. So for accessing timers of the 805 microcontroller, we are using this timers control registers. So this is the 8-bit list. You see this each and every bit register. What is the TF1, TR1, TF0? So TF1 means timer overflow flag. What is the use of this one? This is set. It is equal to the 1. So processor executes the interrupt request. You know that we have 5 types of interrupts are available. Interrupt request. So TR1 to what is the TR1 bit will indicate timer run bit. TR1 means here timer run control bit. TF means a timer overflow flag. Remember this two. You know that IE very well. Interrupt enable or interrupt H here you can call it as. So interrupt enable simply. So this TR1 will indicate the enable timer counter to clear the time and all. So then overflow flag time TF0, TF1 and all. So one is we will indicate the flag information, and one is will gives the running and stop of the timers and counters devices. Then another, these are all comes under the interrupts. All comes under the interrupt. That maybe we can load the interrupt, or we can access the interrupt 0 or interrupt 1 and all. Okay. The next one is the timer mode. Timer mode. So this timer you can operate the timer different modes of operation. This in timer mode, timer control. This will operate in different modes. So you can access or you can working that one in different modes. Okay, we'll use in the timer mode register. So this is used to timer mode register is used to operating modes of the timer 0, timer register 0 as well as timer 1. Okay, these are the register 0 as well. What about this gate register? This where we are using these gates. These gates are used to nothing but these gates are nothing but the clocks here. You can control the clocks. You will see this clock or gate enable bit, or C by TS is nothing but the timer or counter. C is nothing but the counter, T is nothing but the timer. Okay, this timer and counting operating modes, this 2 bit series, this 2 bits, how to how can access the timer mode 0 1 2 and all in series list. If this, you know that a gate, you know that gates are set or reset. How many gates are available? 2 gates are available, gate 0, gate 0. So 2 gates are available, nothing but, so 4 combinations, nothing but this pin, for suppose gate pin, either 0 or 1, either 0 or 1, either gate, either 0 or 1. So 4 combinations are available, nothing but 2 pins are available, nothing but 2 pins mean 4 combinations, that may be 0 or 1. So nothing, if it is gate 1 is 1, nothing but this is gate 1. For suppose this gate 1 is 1, nothing but the timer 1 is operated only if tr1 so is set, nothing but interrupt is high. So gate 1 is 0, nothing but so this put is this timer 1 is irrespective of sequence. So nothing but it may be of interrupt 1. INT means interrupt 1. So this is timer registered maybe of 1 hour. So this is available in the TS series timer run control. Okay, so respectively this has interrupt 0, this is interrupt 0. Gate 1 will depends upon the interrupt 1, gate 0 will depends upon the interrupt 0. Likewise counter and timer registers, counter and timer registers especially used in the port 3 of bits, bit 4 as well as the 5. Then another one, now see this, you know the timer modes, different timer modes series. So 13-bit timer mode, 16-bit timer mode, 8-bit timer mode. Okay, mode splitter, 8-bit timer mode. So you know that different modes of operation, timer modes. So that may be operated by using, we are putting either 0 or 1 in this 2 bits, in this 2 bits, either 0 or 1. So remember, you are mentioning the x is nothing but the see this x either maybe 1 or 0 indicates. Then for next category is interrupt enable. This is also the 8-bit registers. This is also the 8-bit registers. Out of this 8 bits, only 7 bits are used. This is undefined. 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 Okay, see this. What is EA? So what is the EA means? EA means here interrupt enable. You know that EA. You remember where you can use EA and this pin PRG pin are used. You remember that one? This is individual setup to enable enable or disable pins, ET2, then ES as well as serial port interrupt. These are the timer overflow interrupt. These are the again it has the interrupt enable pin and disable as well as timer overflow flag. These are very much interlinked to the TCON. You must remember all the things in description also, discussion as well as additional information. So the next one is the interrupt priority IP register. This is also the 8-bit register. So out of that 8-bit, you know that microcontroller only we have the you have only the 5 interrupts. Okay, so this interrupt priority register. So only 6. We have the 6 priorities are there. 6 priorities. So you know that priorities is nothing but which interrupt is executed first. Maybe interrupt 0 or interrupt 1 and so on. We'll see this. These are the priority input as well as workflow interrupt, priority timer 1 workflow interrupt. And then external interrupt 1 priority. Then these are priority timer workflow interrupt. These are the priority interrupt 0. Then INT 0, we have INT 1 is only there. See this in the pin diagram. You remember the pin diagram. You have only the pins INT 0, INT 1 is there. Okay. The next one is the serial data buffer. So in the serial communication, we are using this register serial buffer register, serial communication. So then another one is the timer registers. So these timer registers are available in two timer register 0, timer register 1. So these are the 16-bit register. These 16-bit registers we are dividing into the 8-bit registers. So timer register 0, timer register 0 register. This one is L means here lower order, H means here higher order. This is the timer register 0. But that they can name as timer register 0, timer register 1. 0 is indicates the register 0. So this is 16-bit register. You are dividing into the 8 bits. See this. These are the 8 bits. Timer register 0, 8 bits. Lower order 8 bits. Timer register 8 bits. Similarly, we have the timer register 1 is also there. This is also the 16-bit register. This 16-bit register you are dividing into the timer register 1 lower order 8 bits. Timer register 1 higher order 8 bits. Okay. Okay. That's it now. We'll. Okay.